Hi, welcome back to our video series on architecture of business applications or some complicated architectures for big business applications for large enterprise clients in the big banking, finance, capital markets and every other sector. Ekdam flat out, okay? Nothing college studenty about it. This episode is the first episode where I'm getting into this zone of these conventional terms: service oriented architecture, this oriented, that oriented, etc. So here, as usual, I'm guessing you are seeing a trend in my style. I try to get a little bit of conceptual clarity for myself into some of these terms so that I can proceed safely. So we all know the full form: service oriented architecture. What is a service oriented architecture? Oh, the system is broken up into multiple services. Very good, very good. What is a service? Oh, service is a part of the system. And that's where you begin to understand that people who talk confidently about service oriented architectures don't have much clarity about what this thing called service is. So let's try to drill down a little. When I started drilling down, I encountered a bigger problem. Forget service oriented architecture. What is the service itself? And then the reason why this word became complicated is because I saw that the word is being used in so many different contexts by my own colleagues without being conscious of the fact that the word is the same but the context keeps changing. So let's try to just look at the different contexts, okay? See, there is one big thing which is an application. I just use the term software application for it. So that's the overall big animal. The application can be broken up into services. I'm going to call it an application service. So from an application come a few application services. Then there is another term which again uses that magic word service. A web service is one endpoint or one function which is being called using a REST API. So a web service performs one small well-defined operation. Okay, so that's a web service. Sometimes people use the term AJAX call to refer to a web service, but never mind that. Web service. The third place where you see service is microservice. What is a microservice? So if these are not micro, then does it mean that the microservice is smaller than a web service? So all sorts of confusion immediately, raise their heads and we are in trouble. So we will get into this in a little more, systematic way now. So let's look at it diagrammatically. The application is one big thing. If I build a monolithic application, it will be one big box like this, okay? And a monolithic modern application will have hundreds of web services. But if I go into SOA, service oriented architecture, then that big monolithic application is broken up into, in this case, 4 different boxes, each is a service. We will still have to address that other question: what is a service? But we at least know one thing: we know where the concept of service fits into the larger scheme. An application is broken up into services, and now if we remove all the services and look at only one service in detail, inside the service, or the service comprises a large number of web services. So an application service is made up of a large number of web services. Okay, so far so good. So what is a service? Definitions in the classic textbook sense don't exist, but I have a definition. I have a conceptual idea which helps me a lot. I think of a service as the software and the data store which implements one object class. If you know object-oriented programming, or if you at least have some idea of object-oriented concepts, you understand that there are object classes and object instances. So one service implements one class of objects in my view and other closely related classes of objects. I'll give you one example. If I have a banking system, then bank accounts are a class of objects. One instance of that class is one bank account. Now, when I record the details of the bank account, I may be keeping all sorts of information about that bank account in that record. That is one instance of the class called bank account. So there could be a service which implements the data store and the code to manage just a class of objects called bank accounts. We'll come to these examples more as we go along. In a banking system, bank accounts is one class. Okay, so it could be one service. Account holders or customers could be another class. So all the information about the customers will be in the customer service. I'm not talking about customer servicing. I'm talking about the software service which implements the data and code for managing customers. So what are the things that you can do there? You can add a new customer, you can delete an old customer, you can update the customer's email address and phone number, update his Aadhaar record, and so on and so forth. And there could be other associated subclasses which are attached to or closely bound to the class called account holder or class called customer. For instance, you could have a subclass called, not a subclass in the usual sense, an accessory class called address. Okay, so account holders, bank account holders are human beings who have addresses. So addresses will also be an accessory class attached to the main class, which is account holders. So this way you can have this idea of a service which is handling only bank account holders or customers. Counterparty banks could be another another class, another service. So everything to do with counterparty banks will be in that third service, and loans could be a fourth service. So you create a loan, so the bank gives a loan to you, a loan record gets added into the loan service. So all the loans are kept in one service called the loan service perhaps. So you can break up a banking system which is a big monolithic or a big black mass of functionality into sub-functions this way, conceptually based on classes of objects. Another example, e-commerce system. The items being sold in an e-commerce system could be one class, customers of the e-commerce system could be a second class, orders, actual orders, which have all these line items and a total and a date and all that could be a third service, and customer support tickets, when customers complain to the company, those tickets could be a fourth service. So you can think about the e-commerce system as being, as having four or more services. So this is a service oriented architecture. Okay. So let's look at it diagrammatically to get a clearer picture. In this diagram, we are showing the classic college student architecture, monolithic. Access comes from the internet, it hits the application code. The application code has a large number of web services. See, this is not service oriented architecture. This is monolithic architecture. One mass of web services is a monolithic application system. It has one database. So the entire set of web services are reading and writing data from one web service, one database. Now this is not service oriented architecture. This is just a scale up. What have I done? I have kept the database common, but I have replicated the application code across 4 servers. Now all the application code is running on all of the 4 servers. So this is just replication. So I have not split the functionality. I have kept the entire functionality. It is still monolithic. It is just copied monolithic, replicated monolithic. This allows me to use 4 servers for application code, where previously I was getting only 1. So this is just a technique to increase throughput, reduce latency. It is not a change in the architecture from monolithic to service oriented. Please understand this very carefully. If you don't get this, you will be in deep confusion. Okay? How do we know that this is monolithic? This is service oriented architecture. The key difference is that a service is a service if it has its own database. So if you say that you are splitting a monolithic system into a service-oriented architecture with 4 services, it means you have to have 4 completely separate databases. So this is the crux, this is the key. Okay? Now, when you have 4 separate databases, it means that the data, the primary copy or the master copy of any data is only in one of the 4. The others can get copies, replicas, but if you want to update something, if you want to go to the authoritative source of, let us say, the bank account data, then you'll have to go to the bank account service. It will have all the bank accounts in its database, but other services may also have copies of the bank account data. So service-oriented architecture almost always, I cannot imagine it otherwise, almost always requires some amount of data replication from one database to other databases, one service to other services. So all data is primarily in one database or the other. Any data, any class of objects will primarily be in only one of the databases, but they may be replicated elsewhere. So the key difference between just a scale up and an actual SOA is that every service has its own private database. Each service gets its own server, it gets its own database, its own application servers. So the application code is executing in containers or servers which are dedicated for that service. Okay? East to west traffic is done using a service bus. So either a message bus or an ESB. ESB is a very common term. It's basically a software layer which communicates, which carries messages from one server to another. So service to service communication, including data replication, is done using ESB. And because your main application is now split into multiple servers, multiple services, you cannot expect the front end, the client code, the mobile apps and the browser front ends to now know, oh, I am querying the bank account service, so I will have to connect to the bank account server. Oh, I am querying the loan service to get loan data, so now I have to connect to the loan server. That would be a royal mess. So you cannot have the front end code being forced to know what your service oriented architecture actually is. Therefore, you have to hide this information, so you need API gateways. So I do not see how you can have a service oriented architecture without API gateways. Infrastructure layers are shared. What this means is, things like login, logout, authentication, authorization, creating a user account. Now, when you create a user account, you are creating it for the application, not for a service. You don't say, I'm creating your login account to log into only the bank account server, but you cannot log into the loan server. That seems a very peculiar way of running the application. So user data, the table of users, the authentication and authorization services are common. They are shared across all services. Logging, where you put your logs, the logging infrastructure should be common. Business rules, if you have a business rules engine, it will typically be shared. Other components also will be shared. And one of the common things we find is that master tables are used by everybody. The master table of PIN codes and the master table of countries, the master table of account types and the master table of depositories and bank branches and IFSC codes and ISIN, for share trading you have this thing called ISIN, master table of ISINs. All of those are master tables. They are maintained by one service and are replicated across all services, so that all the services can get access to the master data without doing inter-service calls. So this is how a service-oriented architecture is structured. So that was a quick overview of service-oriented architecture. And next time we will go into one more step, the glamorous microservice. Thank you for watching and look forward to you joining us in our next episode.